Hello guys and welcome back. In this video we're going to learn how to use to use flip fluids inside of Houdini, how the basic workflow works. And I have these two objects that I'm going to have them basically collide with some water that we're going to place. And in this scenario we just need a predefined container where the water is going to exist, and then we're not going to be continuously emitting water. We're just going to predefine it there, and then we're going to have these two objects be used as a collider. So let's create a new geometry, and let's call this flip source. I'm going to change this to show all, and then we're going to use a node called flip tank, or particle fluid tank, and this creates a domain. You can see the size there, and it's going to fill it with points. And this node is designed to work with flip fluid, so we're going to use it. I'm going to scale it so that we have enough space around these objects. And you can see here, expanding this does not change the point height, and that's because there is a water level, and we're gonna move that up, and that will change the water level. And this is basically a box being filled with points. That's all there is to it. I'm gonna call this null out flip fluid. And the thing that I didn't mention is, with particles we are not restricted with a domain. With flip fluids we are restricted with a domain because the smoke sim requires a domain because it uses voxels. So it's similar to, or exactly the same thing that we have with smoke sims. They are all contained in a specific domain. Okay, so let's go up. Actually, let's stay here. We can do the whole thing. So let's create a dot network. Let's call this sim. And I'm going to copy the path of this node. And we're going to use a flip solver. We're going to need a flip object. And we're going to need a gravity, and that's it. Now with this flip object we have to set the source, and see here we can initialize the state of this flip object using this menu. So I'm going to change it to a particle field, and I'm going to paste in the path for those points. Now the objects right now are being displayed as sprites, and I don't want that, so I'm going to go under guides, particle. I'm going to change this from sprites to particles, so they're just points. And we need to change this domain, this purple domain, to match the incoming domain from the object, and this is defined in the flip solver. So this guy is basically the controller, is basically the solver, and where we have all the controls for the sim. And the domain is defined under the volume motion tab, volume limits, because this is where the volume sim information is coming from. So let's go back up, and actually let's set these guys to numbers that are int. Let's set this to 0, and I'm going to create a floating tab of this. And this way I have the numbers, and I'm going to simply copy this, paste values. Actually I can link them, paste relative reference, copy, paste relative reference. Cool. So let's hit play, and what we need to see is basically the tank just staying there and with nothing changing. But right now it's sinking. The all the fluid is sinking and getting out of the domain. And the reason for that is because we don't have any closed boundaries. So this tank here, it actually has open boundaries, so everything is escaping. I'm gonna change it to have closed boundaries on all of them, even maybe the top we don't need, so positive Y we don't need, but everything else we're gonna keep. So we should see a small change in color, which means there is movement, and that's normal, but everything should stay in place. Now when you have a low res sim, which is the case here, go back up. So when we have a low res sim, we have 800,000, 860,000, which is not a lot. And this is the volume resolution. You can see it here. These are the voxel count, and this is quite low. Now the particle separation controls how dense the volume is, how dense the points are, and the lower this value, the higher the number of points, and this controls this guy controls the grid size, which is the amount of voxels we have. For now, I'm going to set this to 1.75, which will increase the resolution of the volume. And then I'm going to go up. I want the particle separation here from the source to always match the object. So I'm going to copy this, and I'm going to paste relative reference, so that when we change the particle separation inside the sim to increase the resolution, it goes up in SOPs, recook that node, and give us the points that we need. So let's see how much we have now. 5 million, which is much better. Let me change the viewport to pixels. Where is it? Display points as pixels, and yeah, I think that's fine. And then let's look at a few more things. So we have this object here, and under the particle, we change this to particles. You can see it's using V, which is the velocity, and using this ramp to change the color of the points based on the velocity. And right now we're fitting the range of the velocity, the length of the magnitude of the velocity between 0 and 10. So when we have a change in the velocity, it's going to use, if the point is too fast, it's going to use this color. In between, it's going to use this color. If it's slow, it's going to use this color. Cool. So let's go up and bring in these two objects. And what I want to do is I want to compute the velocity for these guys. I want to use, I want to make sure they have proper velocity values. So I'm gonna change it to compute val, and I have points and velocity. I'm gonna change this, connect this to a null. Pardon me. I'm gonna call this tube. And let's copy the path, and let's go to the sim here. I'm going to use a static object. The name does not mean that we can only use a static object. We can use a deforming geometry, and I'm going to merge this. First input, left input is always collision. The second one is the solver. Left input affect right input. And we have our objects. We're going to change this to use deforming geometry, and I'm going to take this to make sure that the geometry is properly interpolated between frames, and this will also help fix various issues if we increase the substeps. And I'm not going to go into all these tabs yet. We're going to explore them as we go. For now, we're keeping everything the default. And when we're going to change it, I'm going to explain the features and why we need to change them. But for now, the only thing that we changed is the particle separation and the grid scale. I'm going to lower this back to 0.2 so it's faster, and let's hit play. And as you can see now, there's collision happening. You can see it here, and as soon as the particle starts moving, we get collision. We get color change here. Cool. So what I'm going to do is let's go back. I'm going to go back up to the object, particle fluid. I'm going to move this up because I think the splash is going to get really high with this example. But what we need to be careful of is that right now we've made that volume field, the smoke sim domain, is much bigger from this to this. So there will be more voxels, and which means it will be a lot slower to sim. So we have to be very, very careful when we change this. I'm going to lower this to 1.5. Maybe. I think this is good for this test. I'm going to write it to disk. Actually, let's import the points. We're going to write them to disk, and then we're going to look at the second process, which is importing the points and meshing them. So let's create a dot import fields, and we're going to change it to flip fluids, and I'm going to drag this here, and the object is going to be flip object 1. See? Cool. So we have the surface, we have the velocity, and we have the points, and we have also it's not going to import the collision geometry, which we don't need. Let's turn off caching, and I'm going to write this to disk. Change this. I'm going to write 100 frames, and I'm going to write them to my cache folder. Okay, I'm going to hit save, wait for this to finish, and then we'll continue in the next video. Thank you guys for watching, and see you in a bit.